Right now, in the middle of the Arizona desert, the United States is attempting one of the most ambitious technology projects in its history, building the most advanced chip factory outside of Asia. This isn't just about a shiny new building or billions of dollars in investment. It's about whether America can truly master the art of semiconductor manufacturing, a craft so delicate and unforgiving that a single mistake can turn entire production lines into scrap. TSMC's Fab 21 is not just another plant, it's a tectonic shift in how and where the world's most powerful chips are made. And the story of this factory tells us a lot about the future of technology, global economics, and even national security. So let's break it down. A few years ago, this site was nothing more than dust and rock. Today, it's home to a $165 billion mega project, a bet that the U.S. can revive its role in high-end chip making. The choice of Arizona wasn't random. Unlike Taiwan, which faces earthquakes, typhoons, and geopolitical risk, the desert offers stability, fewer natural disasters, open land, and proximity to U.S. tech hubs. On paper, the plan looked simple. Transplant a proven TSMC fab from Taiwan to America. But chip making is not something you just copy-paste. At the 4-nanometer scale, we're talking about 4,000 individual steps, where a single variable can kill the entire batch of chips. These variables are tuned carefully to local conditions: the water, the air, the suppliers, and even the work culture. In Taiwan, TSMC mastered this over decades. In Arizona, they had to start almost from scratch. And here's where things got tricky. The dry Arizona ground behaves differently. The air is different. Even the minerals in the water are different. All these tiny changes throw off nanoscale precision. The result? Initial yields in Arizona plummeted compared to the 90% success rate TSMC enjoys back home. That threatened to make the entire project look like a very expensive failure. This is where the idea of the 4 invisible factories comes in. To build a chip fab, you're not really building one factory, you're building 4. One for water, one for air, one for tools, and one for people. Let's look at each. First, water. Chips can't be made without it. Every wafer consumes thousands of gallons of ultra-pure water. Cleaner than drinking water, cleaner than medical-grade injections. A single speck of impurity can ruin a wafer worth $30,000. Arizona, of course, has the opposite of abundant water. It's one of the driest states, relying on the shrinking Colorado River. So TSMC built a massive water treatment plant to strip Arizona water of minerals like magnesium and calcium, and to recycle and reuse every possible drop. Without this, production would have been impossible. Second, chemicals. Critical ingredients like sulfuric acid and specialty gases must be ultra-pure. At first, TSMC literally flew in sulfuric acid from Taiwan because local suppliers couldn't match the quality. That obviously wasn't sustainable, so new chemical plants had to be built near Phoenix just to feed Fab 21. Specialty gases like neon, vital for the lasers that etch chips, still come mostly from abroad, highlighting just how fragile the supply chain remains. Third, air. Clean rooms are the lifeblood of chip making. Even a single eyelash or speck of dust can destroy weeks of work. Arizona's dust-heavy environment made this a nightmare. Fab 21's clean room is one of the largest in the world, covering 160,000 square meters, and air pressure is kept slightly higher inside to keep particles out. Engineers from Taiwan had to fine-tune airflow to achieve cleanliness levels where only a handful of particles exist in an entire cubic meter of air. That's obsessive precision. Fourth, tools. 70% of a fab's cost is in its machines. The crown jewels are ASML's photolithography tools from the Netherlands, each one costing $150 million and requiring a literal convoy to deliver. Installing them in Arizona took months of delicate alignment, because even the tiniest vibration can ruin the precision. And remember, dozens of these machines are needed to run a single fab. But perhaps the hardest factory to build is the people. In Taiwan, generations of engineers grew up inside the culture of chip making. They know how to diagnose problems at 3 a.m., how to tweak recipes, how to live in that world of relentless precision. Arizona didn't have that depth. So TSMC sent American engineers to Taiwan for training, while also building local university programs to grow new talent. Over time, the workforce developed those habits, and by early 2024, Arizona's yields finally matched those of Taiwan, a huge milestone. Now, let me pause for a moment. If you're finding this story fascinating and you think more people should understand what goes into these chips that run our world, please hit that like button and share this video. It helps the channel grow and keeps more of these deep dives coming your way. Okay, let's continue. Even with these successes, Fab 21 still leans heavily on global supply chains. Advanced packaging, the step that allows chips and memory to sit side by side for massive performance boosts, is still done in Taiwan. That means your latest NVIDIA GPU is still tied to factories halfway around the world. Building a fully self-sufficient ecosystem in America will take years, if not decades. And here's another key point. Arizona fabs will always lag Taiwan by 1 or 2 generations. New process nodes like pseudonanometer or 1.6 nanometer are always pioneered in Taiwan, where engineers work through the painful early yields. Only once the process matures is it exported abroad. That means Fab 21 is vital for production, but it won't be the birthplace of breakthroughs, at least not yet. Still, the ambition is clear. The Arizona site spans over 1,100 acres and is designed for up to 6 fabs, plus 2 advanced packaging plants and a research center. This could grow into a full-fledged semiconductor ecosystem in the desert, not just a single outpost. Now here's a question for you. Do you think the United States can really build that complete ecosystem, from raw materials to packaging, in the next decade? Or will chipmaking remain concentrated in a handful of global hubs? I'd love to hear your thoughts, so drop a comment below. I do read them, and your perspectives often shape future videos. Now, zooming out, America's broader semiconductor strategy includes not just TSMC, but also Intel. Intel's nearby Fab 42 is ramping up its own next-generation processes, like Intel 18A, which is designed to rival TSMC's most advanced nodes. The challenge for Intel is scale. Only TSMC and Samsung have the sheer volume to make the economics of cutting-edge chipmaking work. Whether Intel can rejoin that race is one of the big open questions of the decade. The CHIPS Act is meant to help by throwing money at the problem: subsidies, tax breaks, and incentives. But money alone doesn't build fabs. Approvals must be faster, supply chains more local, and perhaps most importantly, talent pipelines rebuilt. You need engineers who dream about semiconductors the way past generations dreamed about Silicon Valley startups. Without that cultural prestige, the U.S. risks building shiny buildings with no one to run them. By 2028, Fab 21 is expected to produce 100,000 wafers per month. That will give the U.S. a genuine foothold in advanced chip making again, something it hasn't had in decades. But let's be realistic. Output will still be smaller and more expensive than in Taiwan, and the supply chain will still be fragile. What matters is that the foothold exists and that it grows. And in the bigger picture, this is not just about economics. Chips are national security. They power missiles, satellites, artificial intelligence, and every strategic technology of the future. Losing control of them means losing leverage in the world. Gaining control, even partial, is a way to anchor economic and geopolitical power for decades to come. So yes, TSMC's Arizona project is a breakthrough. But it's also a warning. This is incredibly hard, slow, and expensive. You can't simply order advanced chip making like a product off the shelf. You have to build water plants, clean rooms, supply chains, cultures, and talent all at once. And that's why this factory in the desert is so important. It's a symbol of ambition, but also a reality check on what it takes to move the beating heart of modern technology across an ocean. If you enjoyed this breakdown and found it valuable, don't forget to hit like, subscribe, and ring the notification bell so you never miss future deep dives. Thanks so much for watching, and I'll see you in the next one.